So hi, um, today we're going to be covering section 7.3, which is over just more properties when we're multiplying with exponents. Okay, so there is a little bit of review there, kind of just going over a little bit about what we talked about yesterday or the day before, but I'm not going to do those today. We're just going to dive right into the lesson, all right? So we've got a couple new properties to talk about today. I'm going to just put a star here next to this one. When we have a power that is raised to another power, like this example here, we have, I think that's x to the y power, which is then raised to the z power. When you have something like that, we would multiply the exponents together. So we add when they have the same base. We multiply when we raise it to a power. So here's an example to look at. We have d to the third, and it's all raised to the fourth. So we simply take the d and then multiply 3 and 4 to get d to the 12th. That's kind of that basic component, that basic idea we're looking for. Now, simplifying powers can require you to use multiple properties. Like I mentioned earlier, once we learn a property, we can kind of build on that property and keep going. And the problems can be more complex or get more complex. So make sure that you follow the order of operations when you're simplifying exponential expressions that are more complex in nature. Just a heads up there. So in the first problem here, we're just looking at what is the simplified form of this expression. So here we have a power and it's raised to a power, or raised to the 1/4. So I know I would multiply those together. So that would give us p to the 1/8 power. So I'm just going to write that out just so you can see it. So I have the 1/2 times the 1/4. So that would give me p to the 1/8 power. That's all we're really doing. That's kind of that basic type problem. Do you know the basic idea? And then we kind of extend it from that point, all right? So in this next example, we can see that the problem has become a little more complex. We have a power raised to a power, but then it's also multiplied again by another term. So what we have to do is think of this kind of in steps. So I'm going to change my color here. All right. So let's think of this as step number 1. We're going to be using the order of operations. So first, we're going to do the power raised to the power. So we're going to take that -3 and multiply it with the 6. So that would leave us with n to the -18th power, and then multiplied by n to the 4th power. Then we would, since we're multiplying those, we would just multiply we would add now the like bases together. So we would add the -18 and the 4. So we would end up with n is to the -14th. So that's step number 2. And then finally, our third step, we would write the expression using only positive exponents. So we would want to flip that to get rid of the negative. So we take the reciprocal and we write our final answer. Now you should also follow kind of these same rules when you're also simplifying numbers that are written in scientific notation. So we'll see a little bit of that as well today, all right? So let's do an example here where we have a little bit of a more complex problem. So we have x squared, and then we have x to the 6th, and that is raised to the negative 4th power. I know it's a little blurry again. Sorry about the copy, but I at least can kind of read this a little bit. So I'm going to start by doing the power raised to the power. So I'm going to start with this first. Kind of think of that as we've got to get rid of those parentheses, right? So I'm going to bring down that x squared, and I'm just going to multiply those two values together. So we get x to the negative 24th. And then they have the same base. So now we would add our exponents together. So we get x to the negative 22nd. And of course, we can't have a negative in the final answer. So now we have to take the reciprocal. So my final answer would be 1 over x to the 22nd power. And that is our simplified answer with only positive exponents, which is what we want to focus on, all right? So those are some examples that deal with this concept. So here's kind of a summary. Here we have a power raised to a power, and it just shows again that we would add, if they have like bases, and we would multiply if it's a power raised to a power. So that kind of thing. Now we have another property here. So right here, I'm going to put a star next to that. That's another property we're going to talk about today. This property is called raising a product to a power. So this means that you have more than one term that is being multiplied inside the parentheses. So I kind of think of this like the distributive property. Like, for example, I know it's a little blurry, but here we would distribute the 4 to the 3, and we also have to distribute it to the x. We have to distribute it to all the terms that are being multiplied inside the parentheses. So that's what it means by product to a power. And we could break that apart. 3 to the 4th can be simplified to 81 because our exponent is less than 5. So we would write it as 81 x to the 4th. Of course, it works the same way if you have a rational exponent. That is actually 3 over 2 there. So we have, again, we would have to distribute that to both terms. And 4 to the 3/2 power equals 8. Remember, your calculator will do that for you. So that's what we would end up with. So let's look at a couple of examples there. In the first example, again, not a great copy, but it says 2z and it's raised to the negative 4th power. So that means I'm going to distribute that negative 4 to the 2, and then I'm going to distribute it to the z also. So we would end up with 2 to the negative 4th power times z to the negative 4th power also. And there's a few things you could do here. You could go ahead and flip them to get rid of the negative sign, or you could go ahead and just find out what 2 to the negative 4th power is. The order can sometimes change as they get more complex, so just keep that in mind. I'm going to go ahead and flip them and get rid of those negative exponents. And then I know that 2 to the 4th is 16. So I'm going to have 1 in my numerator on the top, and then 2 to the 4th gives me 16, and then I'm left with z to the positive 4th power. Remember, when you take the reciprocal, it gets that negative to go away, So then we're left with only positive exponents, all right? Here's another example. Again, a little more complex. That 3 has to distribute to the 7, and then the 3 has to distribute to the m to the 9th. So think of this problem as 7 to the 3rd times m to the 9th, and then that whole value is raised to the 3rd, so that means we've got to multiply because it's a power raised to a power. So we would multiply the 9 and the 3 together there. So 7 to the 3rd is going to give us 343. And then here we would have m to the 27th. So that is what we would end up with for that other example. So just again, trying to expose you to different types of problems. There's also some more examples in your book. So if you want to see other problems, your book is a good reference because a lot of the problems that we do in the notes are different than the ones in the book. So you have a chance to kind of use that as an extra resource if you need it. Okay, going on to example 4. Again, more of a complex expression, and doesn't matter if it has a fractional exponent, or I should say a rational exponent or not, we still use the same rules. So I have to distribute the 4 to both of these values, and then these, since it's a power raised to a power, I know I've got to multiply those together. So I would have 3 to the 4th power times c, and I have 5 halves already, and then I multiply that by the 4th power, times, here we can multiply these together, so c to the 6th power. And 5 halves times 4 is going to give me 10. So I have 3 to the 4th power times c to the 10th power times c to the 6th power. Now, I have like bases, so that means that I can add now those exponents together and simplify also 3 to the 4th power. So 3 to the 4th power would give me 81, and then we add to get c to the 16th. So that would end up being our simplified form for our answer. Now, the other part of that is when we have something in scientific notation. So we can use the property of raising a product to a power to solve problems involving scientific notation. For example here, we would raise both the 3 and the 10 to the 8th. So again, we distribute that 2 to the 2nd power, and then we would multiply those together, okay? So here's a couple of examples. I'm going to run out of time here, so I'm going to pause for just a second, and I'll just write in the solution. That way it'll save a little bit of time, all right? And then we'll be done for the day. So I'm going to pause for just a second here. Okay, so just to save a little bit of time, I went ahead and wrote out the steps here. So you're going to distribute the 3, and then remember when you work it out, if it's not in scientific notation, make sure you change it into scientific notation so it's in the correct form. Same thing for B here. We would distribute the 3, and then we would simplify, so we end up with 8 times 10 to the negative 9th. And that, I think, is the end of the lesson for today. Yes. So your next thing, of course, to do is to start your assignment. So hopefully that gave you a place to start. And remember, always use your book as a resource if you want to see more examples, okay? And I will see you guys later.